Hello friends, welcome to Veterinary Development Academy. In the last lecture, we have discussed in detail about the line integral. Also, we have seen top 30 questions on the line integral. So, in this particular lecture, we will discuss about the surface integral. So, let's start our discussion. So, what is a surface integral? Any integral which is to be evaluated over a surface is called a surface integral. So, let us take an example. So, let us take a function. Let us take a function phi. Okay, so phi is a function of x, y, z. Okay, so any function phi in terms of x, y, z. Let us take an example. Let us take this function as x square y z. So any function in the terms of x, y, z represent a surface in the 3D space. Okay, represents a surface in a 3D space. This is a surface, that is phi is equal to x square y z. Okay, so whenever we integrate this surface, then it has to be integrated in 2 dimension. Okay, so let us take an elemental area ds. So how we can represent this? So this is our function. So we have this as phi dot n cap into ds. This is the general form of the double integral. Okay, so this is our surface integral. How we calculate the ds? Let us discuss on this. And what is this n cap? N cap is the outward normal, outward unit vector, unit vector along outward normal to the surface. Okay, so this is our surface. So normal to this is unit normal vector. This is n cap. Okay, so the outward normal vector will be del of phi. This we have already studied. The gradient of phi is outward normal vector. Outward normal vector. And unit normal vector will be del phi upon mod of del phi. This is unit normal vector. So whenever we have to find a surface integral, then we have to take the projection of this surface either on xy plane or on yz plane or on xz plane. Okay, so based on the type of the question. So suppose we take this projection on the xy plane. Let us take this projection. Okay, suppose this is our projection. This is our projection, that is dr. This is projection as r. Let us take this. So the point here is to remember is that this is our curved surface. Okay, so whenever we take a projection of the curved surface, then this will be a planar area. Okay, so this is our curved surface. So this plane area will be the projection. Okay, suppose we have a hemisphere. Okay, suppose we have a hemisphere like this. Okay, so this is our planar area. So whenever we take a projection on the xy plane, we will get a circle. Suppose this equation is x square plus y square plus z square is equal to a square. So the projection will be a circle like this. This is our projection. So the projection on the xy plane will be x square plus y square is equal to a square. So this planar area is our projection. This is projection. This is our projection. And this is our surface. And projection is like this. Projection. Okay, so whenever we take a projection, the projection is a planar area. Okay, so let us understand this, how to find the value of ds. How to find the value of ds. Okay, so let us understand this from this diagram. Okay, so we have a surface. This is our surface S. So this is our curved surface. So we have taken a projection on the xy plane and the projection is r. Okay, and remember the point here is to note is that this r is a planar area. Okay, and this is our curved area. So we have taken the projection as r, and this n cap is the outward unit vector along the outward normal, and this k cap is the unit vector perpendicular to the this xy plane. Okay, so this angle between both will be gamma. So we have ds cos gamma. So let us take an elemental surface. So we have this as, let us take this as an elemental surface. This is our surfaces. So let us take an elemental surface ds. Okay, This is our projection. This is our projection. So this will be dr. The projection of this ds will be dr. So ds cos gamma will be dr. Okay. So ds will be dr upon cos gamma. Suppose this projection is on xy plane. So this is dx dy. This will be equal to dx dy upon cos gamma will be. So this is our n cap, and the unit vector perpendicular to xy plane is k cap. So this angle is gamma. So the cos gamma will be k cap dot n cap mod. Sorry, write it in other way around. This is n cap dot k cap. Okay, so this is the value of ds. So in the general form, we have f dot n cap into ds. This is our general form. So ds is the project. ds, how we can find? This is from this particular expression based on the projection. So we take the projection of ds on any of the plane based on the type of question. So suppose we are taking the projection on xy plane, then it is dx dy upon cos gamma. So this is our projection. How we can find n cap? So suppose this is function is phi. Okay, so n cap will be del of phi upon del phi mod gradient of phi upon mod of gradient of phi. So this is the value of n cap, and phi is already given. So after that we will integrate it in 2 dimension. So this is the value of the surface integral. Surface integral. Okay, so let us understand this with an example of hemisphere. Okay, let us take an example of hemisphere. So let us consider the equation as x square plus y square is plus z square is equal to a square. This is our equation. Okay, and this is s is our surface. This is our surface. Okay, so how we can do the surface? Take the surface integral. So for taking the surface integral, let us take the projection of this curved. So what we have discussed a couple of minutes ago, whenever we take a projection of the curved area, then we get the projection we get is a planar area. Okay, planar area. So this planar area will be x square plus y square is equal to a square. This is our projection, and this is x, this is y, and z. So we have taken the projection of this surface on xy plane, and this is a planar area. Okay. Similarly, whenever we take a projection on this curved surface on xz plane, then we get a planar area. So this will be, here we have y is equal to 0, so x square plus z square is equal to a square. Okay. Similarly on similarly on yz plane, the projection will be y square plus z square is equal to a square. Okay. So we have the function, we have the phi, the value of phi, the surface as phi is equal to x square plus y square plus z square minus a square. So the unit normal vector n cap will be del of phi upon del phi mod. So how we can find the gradient of phi? The gradient of phi is equal to del phi is equal to I del upon del x plus j del upon del y plus k del upon del z into phi. Okay, and phi is this one. So we have gradient of phi, del of phi is equal to del upon del x of this. So this is 2x I cap plus del upon del y of y square. So this is 2y j cap plus 2z k cap. This is del phi, and del phi mod is equal to 2x whole square plus 2y whole square plus 2z whole square under root. This is equal to so this will be equal to, this is 2 square, so 2 times of x square plus plus y square plus z square, and value of this is a square, so this is 2a. The value of del phi is 2a. Okay, so this will be equal to del of phi is, this is 2x I cap plus 2y j cap plus 2z k cap upon 2a. This gets cancelled, so the value of n cap will be x square plus y, sorry, n cap is x I cap plus y j cap plus z k cap upon, this is the value of n cap. Okay, let us evaluate the value of surface integral. So we have this as f dot n cap ds, double integral. Okay, so we have the value of double integral is f dot n cap ds. Okay, so let us take this along the xy plane. Let us take the projection along xy plane. So this is equal to f, let us take f as it is, f dot n cap. So n cap is x I cap plus, this is n cap, so this is f dot x I cap plus y j cap plus z k cap upon a into ds is, so the value of ds will be dx dy upon n cap dot k cap mod. So n cap dot k cap will be, this is n cap, and dot k cap will be n cap dot k cap, so this is n cap dot k cap mod. So this is equal to, our n cap is this one, x I cap plus y j cap plus z k cap upon a dot k cap, so this is equal to z upon a. So this will be, so the value of ds will be dx dy upon z upon a. This is dx dy upon z upon a, so this gets cancelled. So we have the integral as, this is double integration, so this is double integral along the surface s f dot x I cap plus y j cap plus z k cap upon z into dx dy. Okay, so this way we can find the surface integral. Okay, so this is all about the surface integral. So in this next particular lecture we will discuss problems on the surface integral. Thank you.